Do you know what caterpillars and your favorite vanilla ice cream have in common? These worms are doing what we thought was impossible, digesting what cannot be digested or decomposed. They are eating their way out of a plastic bag like it's a snack. How on earth is that possible? Well, it turns out that scientists discovered plastic-eating enzymes in their saliva. But that's not all. Another group of scientists has cracked the code to turn plastic trash into a delightful vanilla flavor. So here's the big question. If these caterpillars can biodegrade plastic, could they hold the key to solving our planet's massive plastic pollution problem by offering a tasty solution? Let's figure it out. Buckle up, it's showtime. Welcome to Nitzero Club, the place where impactful people come to get inspired. Nature is truly remarkable, and it's showing us an incredible way to tackle plastic waste. Imagine a future where we not only make plastic biodegradable, but also enjoy vanilla ice cream made from recycled plastic and E. coli bacteria. Yes, you heard it right. But before we talk about this idea of edible plastic ice cream, let's start with something small yet fascinating. These incredible caterpillars. These little guys are called waxworms. Dr. Frederica Tacchini, a molecular biologist, witnessed something truly extraordinary during a side project when she put a bunch of waxworms into a plastic bag.
I bumped into the waxworm accidentally because at that time I was a beekeeper, because they live in the beehives. They are considered plagues by beekeepers. So I started cleaning my beehive, putting the worms in a plastic bag, and within a short time I realized they were producing holes.
When plastic touches their mouth, it starts to break down right away. These worms produce a special liquid, which they casually call saliva. But it's way more than that. This saliva contains two mighty enzymes that can essentially make plastic disappear. Here's how it works. When these worms eat plastic, it's like magic. The plastic starts breaking down immediately, thanks to those enzymes. This process happens at room temperature, and it only takes a few hours to see the results. But these worms don't just destroy plastic, they actually digest it and turn it into something useful for themselves. It's like they are having a gourmet meal. Their bodies can react as if they are eating regular food, and they even manage to keep all their fat intact. This means that there's something truly fascinating going on inside these animals. It's like they're turning plastic into their daily meal as if it was the most natural thing in the world. Now the big question is, how can we use this superpower to solve our plastic pollution problem? Imagine if we could figure out how these worms do their magic and replicate it on a massive scale. That's potentially trillions of dollars worth of plastic that we can make vanish. But the real secret isn't just the worms. It's the special mix of bacteria and enzymes that can break down plastic. This is super rare in nature. But why is it so rare? Why is plastic so hard to break down? In nature, most things break down because bacteria have evolved for a long time to break apart everything they come across. Then, plastic showed up, and it's not like anything they've seen before.
Here's a scene that has long since ceased causing any surprise. Dishes that bounce when they drop to the floor.
Today, many people are against plastics for obvious reasons, but when they first came around, they were a big deal for humans. Nature, however, wasn't used to them. Plastics are made from hydrocarbons that come from fossil fuels, and they have long chains of polymers with very strong bonds holding them together. The secret to breaking these connections is something called oxidation, and that's exactly what worms seem to be doing with their saliva, adding oxygen to the plastic. In nature, plastics take from 20 to 500 years to decompose, and they only reduce their size, they don't actually disappear. But these worms can both digest plastic and speed the process by adding oxygen, making plastic break down in hours instead of years. So should we unleash the worms? No, that would be a terrible idea. Remember, they are considered plagues by beekeepers. Even if we focus just on plastic, it's still not fast enough to solve our plastic mess quickly. Just a reminder, being a member of the Nitzero Club means that you don't just want to make a living, you want to design your life. That's why many people are joining our community, and you should too if you haven't already. The real heroes here are the enzymes. If scientists can identify and make more of them, this could be a solution in the future. Scientists are now hunting for similar enzymes everywhere. They have found over 30,000 enzymes that can break down 10 different types of plastics. Even one bacteria found in cow stomachs can break down polyester. But the one that's getting everyone excited is a bacteria called Hydronella sacchariensis, especially its enzyme called PETase. Plastic waste, especially PET or PET, has spread all over the world. Over time, biology has figured out how to deal with some of it. There was a discovery outside of Japan where microbes start living on a plastic water bottle. They were using the carbon in the plastic to survive, so scientists can take this enzyme out of the microbes and begin to engineer that enzyme, making it even better at breaking down plastic waste. We saw that PET plastic takes a really long time to disappear in nature, but PETase can make it disappear way faster, in just a few days. However, it's not the perfect solution yet. To make a big difference, we need to make PETase work even faster. Professor Hal Alper and his team did just that. They called the super fast version of PETase fast PETase. Pretty creative, right? They used AI to speed up this enzyme. They basically used a vast database of all the natural enzymes we know about and ran computer simulations to find out which changes would make PETase work faster. It's like evolution, but accelerated by AI biotechnology. See, AI is not only for you to check the odds of you dating Beyoncé. Yes, people actually do that. This machine learning method makes the enzyme evolve quickly, but it's also guided by observation. They noticed that PETase wasn't very stable, so they used machine learning to figure out which tiny changes would make it more stable. They found a couple of changes that made the enzyme both more stable and much better at breaking down plastic. This new technology opens up exciting possibilities for science. The team isn't finished yet. They are thinking about using this enzyme to clean up plastic that's actually in the environment. That's tough because the open environment can be a bit unpredictable with temperature and pH levels. So having an enzyme that works in different conditions is super helpful. And speaking about unpredictability, check out my episode about the science behind the butterfly effect. I'm pretty sure you're gonna like it. Once PET plastic is broken down into its basic parts, terephthalic acid and ethylene glycol, we can recycle it into new plastic. But it doesn't necessarily have to be plastic. It can also be used for something even cooler, like this. A delicious vanilla ice cream. Well, kind of. But scientists in Edinburgh found a way to turn plastic into vanillin, the main ingredient that makes vanilla flavor. And they did it using E. coli. Yes, the bacteria. Sounds yummy, doesn't it? And for me and anyone craving some vanilla ice cream, the big question is, what we don't know yet about all of this.
We get asked this question a lot. Yes, I mean, it's chemically identical.
My apologies if the next part ruins vanilla for you, but this is the real science.
So vanillin is a compound that's derived from oil that we pump out of the ground. It's the same feedstock that we use to make petrol that we use in our cars. So we, in essence, took one of those enzymes that had been reported to do the initial depolymerization, and then took the mixture of terephthalic acid and ethylene glycol that you get from that, and simply just fed it to our E. coli. But the way that I think about it is, yes, this compound's coming from plastic waste, and yes, it's coming from a bacteria, but I think we as a society are okay with eating food that has oil in it, vanillin derived from oil. So why wouldn't we be okay with having a bacterium produce that for us?
Look, these guys are not trying to sell you vanilla ice cream. They are more interested in doing something better with recycled plastic. There are two ways to deal with plastic waste. One is recycling, where you make more plastic from old plastic. The problem with this is that the new plastic isn't as good as the old one. It's more like a downcycling. It helps in short term, but it still creates waste in the long term. Now what's interesting is upcycling plastic. It's like giving old plastic a makeover and making it valuable again. When you upcycle plastic into other compounds, you put its carbon back into making other useful products that have higher value. While vanilla ice cream can be made from recycled plastic, PET plastic can also be used to create many other things. When you break down PET plastic, you get small molecules that can be used to make lots of different products we use every day. One exciting news right now is turning PET plastic waste into pharmaceutical compounds. This means we can take something harmful to the environment and turn it into valuable products for people. That includes medicine, flavors for food, materials for your clothes, and even cosmetics. It's pretty amazing. But this is just the start of what we can do with recycling plastic. Worms alone won't solve all our problems, but the science behind this is really exciting, and it all comes from nature inspiring us. Now I'm curious to know, would you eat an ice cream made from recycled plastic? Drop your answer in the comments below. As always, keep up the good fight and be wealthy.